Welcome to Vasco Duarte. Basically, he's gonna talk with us about No Estimates. He's the author of the book, the No Estimates, and one of the most, the top inspiration for me when it came. I did a couple of topics before about estimation. He was one of the top people who influenced me to talk about it as well, and provided me with lots of things to talk about. After two times talking about it and being asked the third time, I was like, wait, maybe I'm the problem, right? Like, it's not that the problem persists. Of course, the problem is persisting, even though we have lots of ways to approach it. So Vasco is a fantastic Agile coach, works with security companies right now. He has the Agile Online Summit, the link I sent you guys before the session started to check it out. So without further ado, Vasco, take it away, and we're gonna be very good listeners, and hopefully we're gonna catch as much as possible from you.
Thank you very much, Musab. Thank you for the introduction. I think what Musab meant to say was that anything that he might have said that you disagree with, it's my fault. We'll see how that goes in today's session. So today I prepared a short presentation to kind of get us into the topic and why the topic matters, and then we'll have a conversation. Just a relaxed conversation about what this means and how we might be able to apply it. So I'm going to talk about why all attempts to improve estimation have failed and will continue to fail. And I'll try to explain in a convincing way that that is the case and there's nothing we can do to avoid that fact. And of course, then I will talk about what to do instead. But before diving into that, I wanted to ask you to go to a mural page. I'm going to put it on the chat here, to a simple question. When it comes to having a predictable release in your team, what is currently the single biggest challenge, problem, or frustration right now? You can just double click anywhere and start typing. And the goal with this question is to understand where we are as a community, and also what are the key challenges, the key questions that we are already asking. And that's important because that way we can then explore those questions during the presentation more deliberately. So I'll keep this page open for myself so I can look at it while I'm going through the presentation, and I'll refer to it as we go. I really like that CRs, which I guess means change requests, because of course that is one of the key aspects that we need to account for. And of course, it's also one of the aspects that is so hard to account for. All right, so let's get back to the presentation then. First, I would like to tell you that all of you have access to the book. I'll put the link on the chat for you to go there, and there's no strings attached. If you go there and put your email, you'll get the book in the reply. So just go there, go to that link, you put your name and your email, and you will get the book as a PDF as a reply. The reason why I do this is simple. I get a lot of questions that are answered in the book. I also get questions that are not answered in the book, which is excellent, but there's a lot of questions that are answered in the book, and you can quickly check those by just going there, downloading the book, and then using the book or reading the book to find those answers. The book was written quite a while ago, so it's quite natural that there are different questions these days, and I do get different types of questions than what I was answering at the time when I wrote the book, which was I published in 2015, so 2014, 2015 was when I was writing the book. So obviously we are not the only ones interested in estimates. In fact, this gentleman, Fluvbieri, is a professor who has studied projects and estimations for a long time. And the link to this article is here. And it's a research by Aalborg University. They looked at 258 major international transport infrastructure projects. And I want to emphasize this because this is not software, right? People think that estimates work in other domains. They don't actually work in other domains either. We are not the only ones. Anyway, those projects were from 1927 to 1998. And in that research study, they found that actual costs were, on average, 28% higher than estimated costs, right? Actual higher than estimated, which is what we all experience in our projects. For example, somebody on the mural board says, if the project contains new technology, estimates might be hard to give. Well, I think that the laws of physics have been understood for quite a while. And still, we are not very good at delivering estimates in the domain of physical building, like transport infrastructure. Now, not all transport infrastructure is simple or easy to build, of course, but there's a lot of it that is. But here's the kicker. That study also showed that 9 out of 10, so that's 90% of these projects, the costs were underestimated, resulting in costs overrun. So the average was 28% higher, but 90% of them were underestimated. So let's face it, projects are not the best tool if what you want is to contain costs or hit the deadline. And that's what that article and that research clearly shows. Translating this into a lot easier words, projects are a very bad investment strategy. So if you're asked for, let's say a friend of yours asks you to invest in their company, and they come and say, hey, give me $100,000 and I promise that I will only lose 28,000 of those dollars. That's probably not a good investment, but that's what project management is in practice when it is based on estimates. So projects are a bad investment strategy. But let me show you how bad. Let's take an hypothetical project. And, for the sake of argument, let's imagine that this project has only 10 tasks. One could call it even a micro project, right? 10 tasks. Each of the tasks takes 1 day to complete. That's the estimate, which means that the perfect estimate would mean 10 days to complete the project, right? Because we estimated each task at 1 day, and if it takes 1 task per day, assuming we can't do it in parallel for simplicity's sake, then it would take 10 days. So what happens if we simulate this very simple project here 1,000 times using a Weibull distribution that has been parameterized with information from real-life projects, right? So this is a distribution that we have fed data into as a configuration of that distribution based on actual projects. For example, data like 28% higher than estimated costs. That is something that happens on average, according to that study. When we do that 10 task project 1,000 times, so obviously one would never do this in real life, so we use computers for this, right? Simulating the same project 1,000 times, nobody would do that. So we asked the computer, hey, using this probability distribution, execute this project 1,000 times and tell us how many of them were on time. So on time, even if we take a 10% deviation, right? 10 to 11 days. If the perfect estimate is 10 days, 11 days would still be okay. That's a almost perfect estimate. That's 4.6% of the 1,000 times. Using a parameterized probability distribution, we ran the simulation 1,000 times, 4.6% were delivered on time. To be 75% confident that we would deliver on time in this very simple project, we would have to go 29% higher, which is in line with what we just showed from this study. To be 50% confident, so basically a coin flip on whether you're right or wrong, you would still have to go 23% higher. And as you can see from the histogram, the vast majority of the cases, we are between 20 and 30% overestimate. Now, of course, this is only 10 tasks. And you could say, and you would be right in saying so, that nobody does a 10-task project anymore. Can we do this for a, say, 100-task project, 100 days? That's more likely, right? I'm sure that many of you have worked in projects like this, probably quite small projects. And remember, the problem grows with size. 100 tasks is still not a very big project. Let's say 100 user stories for a team. But the perfect estimation for this 100 task or user story project would be 100 days, right? So delivering on time would mean delivering 100 days later. So we ran the same simulation with the same variable distribution 1,000 times. And do you know what was the probability of a perfect estimate? 0. When we grow the tasks to 100, we will literally never deliver on time. And this is using information or the configuration of the variable distribution from real life data. The minimum duration of the project, minimum, meaning that you would never deliver faster than this, the minimum duration of the project would be 116 days or about 17% overrun. That's the minimum project duration, 17%, 17% overrun. And you can see from the histogram that the majority of the cases were between 22 and around 26% overrun, right? This is where the majority of the cases are. But you can see that there are cases that are 30% or higher overrun. So to be 75% confident, we would say that the duration of the project would need to be 126.17, so let's say 127 days. And to be 50% confident, that's, coin toss accuracy, it would be 25 days. Now, I want to call your attention to this specific fact here. It's still a very simple project, only 100 tasks, only 100 days. But the probability of delivering on time is 0. Another important question for us to ask is, okay, but how quickly does it get that bad, right? Because this is 100 tasks, the other one was 10 tasks. But how quickly does it get that bad? So I asked this question, in other words, is a project fragile to the size or number of tasks? And for any one of you who has practiced Agile for any relatively significant length of time, you already know the answer to this question. And the answer is that project estimate errors, so estimate errors, grow faster than the size of the project. So the relative error in estimation will be higher the bigger the project you're in. And this, we already have a lot of data to show. So this in itself would not be a big news, if you will. But here's how fast it grows. If it only has one task, if the project only has one task, then you're almost certain of delivering on time. The probability is 1. If the number of tasks goes to 2, the probability is already 40%. If we go to 5 tasks, the probability of delivering on time is already below 20%. To 10 tasks, 10%. 15, already nearly 0. and the max that I did the simulation for was 30, and that is practically close to zero. So this is what I want to tell you. Large projects are worse than small projects when it comes to delivering on time. That we already knew. But here's the thing. Even relatively small projects, so 5 tasks compared to 1 task, right? Even relatively small projects have a huge impact on their ability to deliver on time because of the number of tasks growing, even from 1 to 5. The speed at which the errors accumulate is so much faster than the growth in number of tasks. Here's the problem. When you study estimates, when you read the books and go to school and learn about estimates, they'll tell you that errors are linear. But if the errors were linear, this would be the curve that we would observe. As we grow the number of tasks, we would see a linear decrease in accuracy. But we don't. We see an exponential decrease in accuracy. In other words, projects are fragile to their size, tasks, and duration. This is because estimation is a fat-tailed process. For those of you who are not familiar with this, what this means is that small errors have outsized consequences. Small errors have outsized very large consequences. And all of you have experienced this in practice, because you know that sometimes there is one task that gets delayed, that task has an impact on another task which also gets delayed, that second task is already starting late, and it will probably be late itself, which then grows and grows and grows. And we know this as critical chain in project management, and there is no way to recover from delays in a critical chain within a project, which means that errors accumulate. They grow with time. They grow with number of tasks. Now, the important thing for me is for us to understand that what we were promised when we studied estimates, when we studied project management, is this curve. But what we observe is this curve. This is very important. Why? Because there are still a lot of people out there promising that if you could just estimate a little bit better. And in fact, the data shows that it doesn't matter how well you try to estimate, because projects are fragile to the number of tasks. And of course, there's a bunch of examples there. I'm just going to quote 2. The F-35 project budget overrun, which was supposed to cost between 94 and 122 million. And in 2018, it had already cost 1.5 trillion. I'll let you do the math as to how many times that is more expensive than planned. And the Berlin Airport project, which is something that started with a project of 2.4 billion. By 2019, it had grown to 8.48 billion, and 2019 isn't even when it was open. It took a few years more to open it. So now it's time to think about, okay, but what else can we do? So here's a new solution to the be on time and on budget problem. One of the things that one of you mentioned in the mural board was that the dependencies outside the team affect the rate of delivery or the predictability of the team. And of course, everybody would understand and agree with that. But here's the problem. We already know how fast the team can go if we just look at their throughput. We know this from networks, right? We can see here that networks are not stable. Big valley there. This is throughput on a network. They are not stable, but they mostly vary their performance within a range. And this range is incredibly important information. This is network throughput. This is team throughput. And you can see the same pattern, right? there's a dip here, then we are oscillating at about the same level, then there's a dip, then we are oscillating at about the same level, and so on. So we can say that there are clear limits to the maximum and minimum performance of this team, except for some outliers, like we can see also in communication networks, right? If we accept this, and it takes some work to accept it, but if you look at the data from your teams, I'm pretty sure you will see the same pattern, then we can see that our rate of delivery will be the same over time. Again, same meaning that it will vary between an upper limit and a lower limit. It's not exactly the same, but it varies between two values that can be known. Now, we also know at all times how many items we have in the backlog. In fact, many of you might be using simple tools like Trello or Jira, so you will know exactly the size of your backlog at any point in time, and that information is readily available. If you put these two pieces of information together, if we know how many items there are in the backlog and we know the rate of progress, then we can continuously track how many sprints we have until we deliver the whole backlog. If this is your backlog size and this is your progress so far, then we can use those intervals I showed you a second ago to project the likely delivery date. And it would be here, right? It would be in this interval. If you think this is too late, well, then you have an option. You can, for example, at this point, reduce items from your backlog. And then if you start from here, then you're more likely to deliver on time, right? And this delta here, you can simply know by knowing how many sprints are we over the expected or necessary release date, because many companies actually need to deliver on a set date. For example, I used to work in a consumer software company where if we didn't get ready in time for Christmas, we would lose in 2 months 1/3 of the yearly sales. So of course we wanted to be on time because it had huge impact on the profitability of the company. So in the No Estimates book, and the link is in the chat, so remember to check it out. In the No Estimates book, we talk about how to establish a trustworthy backlog, right? Because this is important. It's not just a random collection of random ideas. We need to have a structure and an approach to keeping that backlog. We also talk about how to track the rate of delivery. There's some steps to consider there. And also how to use the data points to forecast without estimates the release date, right? And it's going to be something similar to what I just showed here. In fact, this graph is from the book. And finally, if there's one lesson you take from today's presentation, it should be this. Scope management is the only solution to the deliver on time problem. If what you want is to deliver on time, we already know the solution for that, and it's not estimates. It's continuous delivery together with aggressive scope management. If you use something like this is also known as a burn down. I only use the number of stories here, no story points, just the number of stories. This is important because, of course, if you would have story points for the stories, then you would have less accurate data, but also you would have to have the whole team estimate the stories instead of doing something much more important and useful, which is to break stories down into small components, which is what I talk about in the book. How to do that so that you still keep the vertical stories and you deliver more often, you deliver the right valuable stories. Okay, this was the presentation originally, but I decided to add a bonus at the end. So I recently discovered a master thesis that corroborates my demonstration, the demonstration you saw at the beginning of this presentation. You can see that here. It's on Twitter, and you can find it in this URL. Don't forget that the letters or the URLs are case sensitive, so you need to capitalize these words. Right, so this master thesis collects data and then analyzes data from more than 3,000 projects. And here's some highlights. First, the outliers on the data, outliers meaning that they are so much late than the average that the researchers, the estimation researchers, just don't consider those projects in their analysis of the results. But when the researchers were looking at the data, they saw that the outliers are so frequent that the noise, i.e. the impact of the outliers, completely erases the value of everything else. In other words, if you want to study the error of estimates, only the projects that are late, because usually they are very late, matter in analyzing the accuracy of projects and estimates. Why? Because the outliers, as they say in the research paper, the outliers are so big, so disproportionately big to all of the other projects, that they drown all of the signal in the data. So, in other words, even if you have data from actuals, you don't really know if you will be late because the outliers are only visible in retrospect. So if you're using estimates and everything seems to be going fine and you're confident because the actuals so far have been good and you're tracking to deliver on time more or less, it's enough to have one outlier in your project to completely derail the project. We're talking, 100% delay, 200% delay. Another interesting example from that thesis was when they looked at Kmart. Kmart is a supermarket chain in the US that went bankrupt, at least in part, due to a failed 1.4 billion USD IT project. And this is the most important aspect. The IT project was 1.4 billion, and Kmart went bankrupt when it declared a loss of 244 million. Why would Kmart do a 1.4 billion IT project? Well, the answer is simple, because somebody estimated and they thought they were going to deliver on time. Of course, they didn't, and the company went bankrupt. But this one is the kicker. The people who wrote this thesis, when they looked at what estimation researchers did, they recognized that researchers, when faced with a large amount of extreme cost or schedule overruns, these are the outliers that I talked about a moment ago, right? When faced with a large amount of extreme cost and schedule overruns in IT projects, they chose to ignore those and use only the observations that fit the normal distribution, which is thin-tailed, not fat-tailed, as we already know and have established is the case with estimates. In practice, estimation researchers hid the fat-tailedness of the estimation errors. So the only reason why we believe estimates can actually work is because when researchers look at the data, they conveniently ignore the data that does not conform to their expectation of reality. So the data is screaming at them saying, hey, pay attention, this is not going to work, the project is going to explode in your face. That's exactly what the data says, but they decide not to listen to it because the data does not conform what they expected the data to be. So that was my presentation. I'm sure you have a lot of questions and I'm happy to answer those. But if I have one last parting word of advice for you, it's this. Read the book and start experimenting with the data you already have to validate for yourself that you actually have much better tools to predict the release date of your projects, and those tools work much more reliably than estimation. Thank you, everybody.
Thank you, Vasco. Was fantastic and insightful. Lots of statistics and information because it is all about the numbers in the end. There are tons of things. I think I'll start with asking I didn't see anyone in the chat writing, so I'll start with asking a couple of questions. First, I'm curious because we talked before you joined, and what's interesting is people who have experience level beyond one point started saying there is no solution to this estimation problem, right? Like we can't estimate better. People who are a bit less experienced, like, okay, we came here to learn how to estimate better. So it was interesting, maybe a question of observation. We don't have data for this, of course, but at what experience level do people just give up on actually estimating? Like that would be interesting to me as well.
That's a very good question. So, of course, there are some people out there who still believe that estimates can work and will even sell you methods to improve your estimates. They often forget to mention that the methods are so cumbersome and expensive that they end up costing more than the projects they're supposed to estimate, that they will not mention. But my point really is to say that we already have tools, and I'll share that slide again. We already have tools that allow us to predict when a project is likely to go to be finished. And that's something like this, right? So we have the backlog size. Oops, wrong button. We have a backlog size, and we know the size. And if we know the rate of delivery, I call this the Disneyland problem, right? Let's imagine we are 500 kilometers away from Disneyland. If you drive at an average of 100 kilometers an hour, assuming you're taking on highways mostly, then excuse me, then you are likely to be there in 5 hours. Now, you might want to stop, and of course that increases the time it takes to get there, but you get the point, right? If you know the rate of delivery, which we should know, we just need to look at the data. And if we know how much distance we need to cover, or in this case, how many stories we need to deliver, we know when we're going to be there. And this information, even though it is simple, it's actually quite accurate. All the studies that I have seen and the ones that I have done myself show that just counting the number of stories is actually sufficient information. This is the problem, the point that I want to make, to identify when you need to start reducing the scope. Because that's really the key question we need to be asking. If your goal is to deliver on time, and it's not always like that, but if your goal is to deliver on time, then the only way to do that is by aggressively managing the scope.
I think this leads me to the next question. Why do you think, I'm not going to have any assumptions, so I'll keep it as open-ended as possible. Why do you think estimates are still a sticky problem? Like, even though, as you said, it has been a problem since the 20s, right? Like projects started. One example I actually give is the Sydney Opera House. Like it's such a high profile event, project, and it's like the signature, and still even that was very behind schedule. So what do you think comes into play when it comes to that sticky problem? Is what comes into play? What happens?
Yeah, so just to be clear, I'm not arguing that you should use this method in construction projects. I don't know anything about construction. So I'm talking about software projects, just to be clear.
Yeah.
And in software projects, I think that one of the key aspects that forces us to be stuck in the idea or expectation that estimates can actually work is that we still live within the mentality of waterfall. We haven't really yet embraced Agile. Because if I want to take this a little bit further, what Agile says is that you just need to know what value needs to be delivered, and then you need to experiment. You need to quickly deliver something to the market or to the customer, collect feedback very early. This is in the Agile Manifest, 2001. This is nothing new. I'm not saying anything new. This is not an interpretation. It is actually written there, right? Delivering quickly and collecting feedback. That's all we need. When we are there, when we're delivering quickly and collecting feedback, then most of our time is around scope management. It is no longer about estimating, pricing, or sizing. Because and some of you may have experienced this already, sometimes we start with an idea for a project and we're halfway there, and we say, hey, we're done. We got enough value, we don't need to invest anymore, right? At the beginning of the presentation, I said projects are a very bad investment strategy. Implicit in that phrase is also that anything we do is a bet, it's an investment. And that investment is more important than how much it takes to get there. Because in fact, and anyone who works with software will know this, there's a million different ways to deliver the exact same value. We only need to find one that works. And it is finding that one way of delivering value that works, so the right feature, the right interface, the right communication to the user, whatever that might be, that's what we should be focusing on, right? And if we add to this the fact that 20% of the features in any given project deliver 80% of the value, then you already know that the majority of the work we do isn't actually that valuable. So we should really just focusing on delivering what's valuable. And for that, we need to discover it. And if we start from that perspective, that we are constantly discovering what we should be delivering next, then we can't even estimate because there's nothing to estimate, right? Estimates only make sense to start with when we start from the perspective, the assumption, that we already know everything that needs to be done before we start the work. And as my friend Woody Zuil very often says, it's in the doing of the work that we discover the work that must be done.
Yes. Thank you. Thank you very much. Now, any questions? No one put anything. And if we want to stop sharing so we can actually see people. Okay, Muhammad. Let's start with Muhammad, Sahib, then Beshat.
Okay.
الكاميرا بدل ما يطفي المايك.
Sorry, I closed the camera instead of opening the mic. I think that's
Yeah.
that's a project management issue. Still, regardless to that, really appreciate your feedback and your expertise and insights into this particular topic. Again, myself, I've already struggled with the same concept over and over again that, in fact, do indeed projects are very, very fragile. And a lot of people that you end up working with don't really see that particular side of a project. They just see the plan and they want to stick to the plan and they want to stick to the delivery. And there's a lot of things that go in between that, just completely alterates the whole approach itself. Now, I saw something interesting in one of the slides, which is the one be on time and be on budget. And I felt that really, my question was towards it, meaning that is capacity planning a way to estimate, or that's a little bit pretty far off from how we can actually estimate instead of counting or doing the backlog management, which equals also time management at the same time? These are I think, two questions that are somehow related to each other in a way or another.
Great question. So first, what do you call capacity?
Capacity planning, at least in my humble perspective, it is how many story points we can allocate to the engineering team within a sprint. So we can actually identify how many tasks that can be delivered at the end of each sprint. So we don't end up with a lot of spillovers, and then we have to re-estimate again on the next upcoming sprint what needs to happen or where we left off or what the QA has came up with, bugs, issues, and etc.
Right. Okay, so what I talk about in the presentation is called throughput, right? And throughput, very simply, is the number of stories delivered per sprint, if you're using Scrum, or per unit of time, if you're using Kanban. So throughput is independent of what you just now called capacity. Now, it might be that they are the same number because you also said it's maybe the number of stories we can deliver by the end of a sprint, right?
Sure.
But the way I look at it is this. A system that we are trying to evaluate the capacity for, let's say one team, two teams, or even 100 teams like I did, you can't go and analyze that system in detail necessarily, but you can look at it from the outside and measure the throughput and cycle time for that system. right? In one of my original projects where I started to use no estimates, we had around 100 teams distributed all over the world. So obviously it's quite simple to understand that it's not possible to estimate in detail how that project is going to go, because there's 500 people involved, more or less. And you're going to spend all your life just collecting the details of the estimate before doing any work. Now, that's not possible. So the way we did it, of course, is to look at it from the outside, measure the throughput, meaning how many features are we delivering to production or a production-like environment per week, and then looking at the size of the backlog and projecting that to the future, which gave us the release date. So in this particular perspective, the perspective that I take, the capacity is that of the system, not of one team. This is important because a system is stable, a team is not necessarily stable. And then the second thing is that for me, as the, let's say, the owner of the company or the investor, what matters is what gets delivered in the end, not what one team does, but what the whole system does. Because, for example, in that big project that I just referred to, the project manager thought that by asking every single team if they would be on time, that would be enough information. But of course, you all know that if you have 2 or more teams, even if they all think they're going to be on time, it's enough for one of them to be wrong for the whole project to be late. And this happens a lot. This is a very common problem. So that's why we choose to look at the capacity as throughput for the entire system, and that's the capacity of the system. And there's nothing we can do to change that capacity. We can experiment to try to figure out where are the bottlenecks, where is work getting stuck, and so on. We can do that, right? Like value stream analysis and all of that. But capacity in any non-trivial system is largely fixed. It can be observed, but it cannot necessarily be changed.
I see. So looking at capacity is a whole different approach than actually estimating what we can do by actually managing the backlog itself and being able to see a clear timeline of delivery.
Check out the book, because I explained that in detail in the book.
I did just receive my copy. Thank you a lot, by the way, for the link. I really appreciated that.
That was a great surprise for everyone. So thank you for that. Question from Abdullah Muhammad. What I understand is that depends on the scope and how it will serve the long-term project. Dream big and then get estimates, then minimize your dream. Then minimize your dream to meet the estimation of رائد دير بالك. Minimize the dream to meet the estimates on the runway to take off before the runway ends and crash your plane. Okay, is that the magic solution? Am I right?
Thank you for that question. And of course, I appreciate the fact that you use the word dream. But don't forget that in most projects, most of the work is actually not delivering very significant or any value at all. So in fact, it pays off to reduce the scope of a project as we go. Not because you're going to crash at the end of the runway, but because most of the work is actually not that useful. So if we think about somebody using the software we're producing, if we involve them, right, if we bring the customer into the room, like they used to say in extreme programming, then we will be able to find out what actually delivers value. And instead of reducing, quote unquote, the other things, we can actually decide to focus on what delivers value. And that's what I'm arguing for, right? And I'm not the only one. People who have nothing to do with no estimates are also saying this in general, which is this concept or idea that what we need is to focus on what delivers value to our customers rather than maximizing the amount of features delivered. So totally different problem. And when we focus on delivering value rather than maximizing the number of features, then we don't need estimates anymore, because in fact, we should be delivering on a regular basis, and when it's enough, it's enough. And that's what the core of Agile is all about. It's not about maximizing the amount of work done, it's about reducing the amount of work done while focusing on value and delivering a lot more value. So it's about maximizing value, maximizing the impact on the customer and user's life, not the amount of features.
Thank you. It's interesting, even before you came, people were talking about preparing excuses when we run over time. Like basically, so it's like all the effort that we're putting instead of adding value to the customer, we're spending making excuses. I think the other thing that I'm kind of getting from what you're saying is maybe prioritization, because maybe it comes from management, is harder to do than asking teams to estimate better. So maybe that's part of the dynamic as well. What shouldn't we do? No, I want everything. Like, okay, we get it. If you want it on time, then you can't have everything. So what? So I think that is a difficult conversation as well. Yeah, outcomes instead of output. Thank you. Mahdi asked a question. Even if we are trying to embrace Agile and the way of managing estimates, I think a lot of business owners and project managers are coming from the construction industry and waterfall mindset. How can we manage their influence and manage their expectations?
That's a great question, and one that I get quite often. And what I tell people is focus on convincing yourself. The moment you believe you can work without estimates, nobody can force you to work with estimates. Very simply, if your team believes that they can be predictable without using estimates, and they can, they do need to believe in it first, so they need to do some experiments with their own data and so on. But the moment they believe in that, then the estimates don't matter. Like one of the experiments that I talk about in one of my talks, where a team at Microsoft just decided to use random numbers to size their tasks. And funnily enough, they used 3 sets of random numbers. First it was 1, 3, 5, then it was 1, 2, 3, and then it was 1. And the difference in the projection, using that burn down that I showed in my presentation, the difference in projection was 8%. Now, most project estimation errors, and that's the ones that the estimators accept, is going to be on the 25% range. So when changing numbers in an Excel sheet, right, it's simple to do. You just go and search and replace. Changing numbers gives you a difference of 8%. Then estimates don't make any sense.
Even if it works, it doesn't help. There's another comment here, like we had discussion before. I thank Ahmed for mentioning that. It's like sometimes management comes with the estimates ready. Like that's even a bigger kind of problem. Like, okay, now this is the scope you need to finish by that time. Well, what do you know what comes into it? And sometimes we discuss this, it's delegated to the technical lead who then takes the responsibility and then leaves the company after that. So thank you for that. Here is the comment Muhammad was talking about, how the stress and the estimation through Agile is putting too much constant stress on people. So story points and story estimates. Unlike waterfall methodology, where stress is mostly for the short period of time. At the end of the project, maybe they get stressed, not every sprint. I think that's an interesting point.
I think Mohammed must be a very young person, because when I started in the software industry, some of my colleagues went on a sick leave and never came back to work, and that's a lot more than stress. Like, they didn't even have the option of starting to drive and become delivery or taxi drivers, because they burned out and they went to hospital and they were out of their profession because of waterfall. We called it back then crunch time. So yeah, if you're young enough, you've never seen that. So I understand why you would say that Agile is stressful. Yes, it is. Everything in life is stressful if you want to be good at it and if you want to deliver. Stress is a side effect of owning the responsibility of the work that you do. Sometimes it's too much, so we should take a step back, and sometimes it's not enough, and that's fine too. But to say that waterfall was not as bad or even worse than whatever you may be experiencing now, I think that just shows lack of knowledge.
I think in addition to Muhammad's point, there's a lot of Agile abuse. So Agile naming under waterfall structure. So maybe that's
Definitely.
I'm pretty sure that many project managers would argue that there's a lot of abuse of standard waterfall as well, right? So what I'm trying to say is stress is a difficult and a very uncomfortable aspect of the software industry. It is not related to process. Yes, a process has a different profile of stress level than another process. But here's the thing, the teams that deliver software every day, and every day they know the software will work because they have unit tests and test automation and so on, they don't need to stress.
Yeah. Cool.
It's just a matter of clear scope. That's it.
Clear scope. Yes. Let's take the last question, and then after this we'll continue the discussion, guys, because Vasco will need to leave. Let's assume you're delivering story requirements, and after certain number of sprints, a flood of change requests. Maybe the back to the change request. Can apply this measurement management will be so happy because they receive profit. This is the real situation I am facing.
Yeah. So a great question, Ahmad. If you look at software delivery in an agile context where you have a backlog of items and you deliver the things that are in that backlog, which are prioritized in force ranked prioritization, there is no change request because everything is a change request. You just go through the items as they come through the backlog. So you can still use the same method. Now, there are different profiles in a project, right? If you're at the beginning of a project, it's quite natural to have a different throughput than if you are in the middle or in the end of the project. Every context has an impact on our throughput. So, for example, if you are in a phase of the project where you get interrupted a lot, typically close to a release, then of course that's going to have an impact on your throughput. This is why with the teams that I work with, I try to help them move to continuous or daily delivery as soon as possible, because then that allows them to be even more predictable. This is an important aspect. Continuous delivery increases predictability, which is one of the things we're looking for, right? Like it's one of those goals that we say we have. So continuous delivery is a much more effective way to become predictable than any form of estimates, even when you get interrupted and there's a lot of change requests coming your way.
Thank you, Vasco, so much for your time. We really appreciate it. Hope as many people will actually come from Agile Jordan to the summit, and also from the other product folks and Google Developer Group communities.
Absolutely.
Thank you so much for the time. We hope to collaborate even further in the future. We love the talk, and we thank you so much for it. Thank you.
Yeah, absolutely. Thank you, everybody, for receiving me in your community and listening to these thoughts. And I hope that you got inspired to try something new tomorrow.
Thank you. Thank you very much.
Thank you.
Bye-bye.
Bye.
Bye.